Okay.
That works.
Okay. I'm going to send the presentation now.
Okay.
So, hi everyone. Can you see me or not? Maybe not.
They can't see you right now.
Okay, that's fine. I will be the ominous voice. So, um, I'm joining you all, as you might have noticed. I'm not in Fort Collins right now. I'm at a workshop called Growing Water Smart. It's hosted by the Sonoran Institute. It's focused on helping communities integrate land and water planning together. And I'm being a facilitator at this workshop, and it's in Grand Junction. So I am on the West Slope. Very excited to be here, but not in Fort Collins. So I apologize for joining remotely. And today we're going to hear from Dr. Tim Gates, and I'll introduce him in just a second. We're going to talk about South Platte salinity, but before we do that, one important announcement: we have the South Platte Forum coming up on November 30th, and there is a free student registration available, and I sent out an email in Canvas about that. And so if that is of interest to you, it's about the South Platte. They address issues in the South Platte, and it's a great opportunity for everyone. So if that's of interest to you, take advantage of that free student registration and sign up. And if you have any questions, just send me an email. If you can't find how to register or something like that, just let me know and I'll help you out. Looks like you're getting my slides pulled up. That's great. Thanks.
Yeah,
one
let me
other
get
quick
it
announcement.
onto.
Go ahead.
I got to get it onto the screen here in the classroom.
Okay. One other quick announcement. So for those who are doing the Your Water, Your Life contest, there's 6 of you. I created in Canvas, there's a calendar sign up slot. There are 20-minute slots on October 31st and November 7th during my office hours from 2:30 to 3:30. So there's 6 slots. Please sign up for those on Canvas. You just can go in and sign up for one of those time slots. Let me know if none of those times work for you, and we'll find an alternate time. Like if you have classes or something beforehand, we can find an alternate time, but please do that. October 31st is already next week, so sign up, and we will do our the check-in that we have to do, the midpoint check-in. And it's just going to be a short conversation to talk about your project and progress that you've made, challenges, successes, etc. And if you have any materials or things to show progress on your project, please send that to me before the meeting. Any questions from students before I get into a quick presentation here?
Doesn't look like it. I'm still working on setting that as the screen in here.
Okay. All right, so while he's still pulling up my slides, I'm going to talk today. So I am involved with South Platte Salinity as a kind of convener and facilitator of the South Platte Salinity stakeholder group. And I wanted to just share some of that work with you all, and some of that background information before Tim gets into all of the technical parts about South Platte salinity, and just kind of the importance of the stakeholder conversation around that and some of the work that we've been doing. So are we there yet, Justin?
It's still just not wanting to swap 1 and 2 right now.
Okay. Well, I will just talk about it without any slides, so that's fine. for now. So the South Platte Salinity Stakeholder Group, it formed in about 2020 and started just based on the need to get more collaboration and discussion and coordinated research in the South Platte River Basin about salinity issues, because people started realizing, hey, this is kind of a problem and something that we needed to start addressing.
There we
The
go.
focus
Yeah,
area. Oh, great.
I think.
Okay, thanks.
Yep.
You're going to have to go through the slides for me. Yep, so I'm on that one now.
Perfect.
Thank you. Thanks, Justin.
Yeah.
So yeah, the focus is essentially, it's not entirely up in the mountainous areas. It starts at the Waterton Canyon and goes all the way out to the Colorado-Nebraska state line. That's the area, that's the region that the stakeholders decided they wanted to focus on. And it was initially funded by Colorado Water Conservation Board Water Supply Reserve Fund grant. The stakeholder group drafted a charter in December of 2021, and they meet roughly quarterly. I am, as the Colorado Water Center, we are the ones that are kind of coordinating the group, and Northern Water has also helped with some of that facilitation when Water Center staff essentially were turning over, like we had some replacement of positions, including my position and the director position as well. So next slide, please. So the goals of the stakeholder group are really just to bring folks together to discuss concerns and needs, and use those concerns and needs to guide ongoing and future salinity research. So, make sure that the science that is being conducted is really comes out of the stakeholder discussions, and then based on that research, form collaborative solutions going forward. Next slide. And so there's a lot of different stakeholders that have been engaged to date. These are folks that are, we're currently involved, and it continues to expand. We're looking to get, some environmental contacts in here, but it involves municipal groups, so folks from the metro area, and that essentially are, parts of their wastewater treatment is going into the South Platte, and then agricultural representatives, a lot of the water conservancy and conservation districts, government representatives, and then the research institutions, including Colorado State University. And then we have one nonprofit. I think there's a couple more that we need to include in that list, but a variety of different interests and backgrounds that we're representing. Next slide. And Justin, you're going to have to kind of buzz through this one because it's like a lot of animation. So this is kind of the process that we determined. You can just keep clicking through. And it's essentially a circular process where we identify our issues and needs. We formulate research questions and guidelines, and then researchers are submitting proposals to a technical team. That group reviews proposals, fund the proposals, share results and revise information, and then go back to the drawing board. So keep clicking through, Justin.
Yeah.
Yeah. And eventually we get back to, okay, let's reassess the problems and identify the next, what are our issues now? What are the needs? How have they changed? At the center of that is our role, where we're coordinating and facilitating these processes. Next slide. Or keep going. Yeah, there's less. Okay. And so in that process, so where we're at right now, we identified the stakeholder concerns and needs that ranged from a variety of different things involving salinity, from different pressures on the system, including there could be policy issues, there could be there are water rights concerns where quantity is prioritized over quality, future climate change, water projects, increasing water demands. And then kind of the impacts of salinity from the physical aspects to the economic, to the social, cultural aspects. And then kind of off of that, what are the actual needs of the stakeholder group? And that relates to our process, more data and monitoring, modeling, more hydrological information, characterizing the problem, and then coming up with some solutions. So based on these needs and concerns, we recently developed our research questions, which that is going to essentially drive the research going forward. So next slide. So the first question has to do with, what are the salinity sinks, sources, and distribution, and the concentrations and loads basically throughout the watershed. So what are, and to answer that question, we have to know, what are the hydrologic inputs and outputs? How does salt accumulate over time and where does it go? Very important to a lot of the stakeholders are some of the different constituents, and they have different meaning for different groups. So yeah, next slide. Question 2 is about the effects of land and water management on the sources and the concentrations and loads. So how do those interact? Particularly agricultural practices and irrigation practices. And I know Tim's going to talk about that, I think, a little bit, and then kind of the effects of the municipal and industrial water use and treatment on salinity. Next slide. And then what are those impacts? And so is it actually a problem, and for whom? So how is that being felt in the system, and where? And if it's not a problem now, it will definitely be a problem in the future. And so where and when will that be a problem? And then what are implications for these different aspects of the system? So species, groundwater, agriculture, municipalities, and other states, potentially like Nebraska. Next slide. And then lastly is just identifying mitigation strategies. So by source, what are both feasible and effective mitigation and management strategies to address salinity? So you can end my presentation there, Justin. And I will take maybe one question while Justin is pulling up Tim's slides. Are there any questions about kind of the stakeholder process? I just wanted to give a little kind of overview of that, because I think it's important as we think about kind of complex watershed issues that you can't really address in a silo or just talking to one person. I mean, this is a complex issue that involves a lot of different folks. So that hence the importance of the stakeholder engagement. Any questions?
Looking good.
Okay, and so now thank you so much, Justin, for helping us get this set up. And thank you to Dr. Tim Gates for agreeing to speak more about salinity in the South Platte River Basin and give us really kind of a good understanding of the issue. So Dr. Tim Gates, he's a professor of civil and environmental engineering at CSU. Over the years, his research has focused primarily on agricultural water systems, especially how streams and aquifers interact with irrigated agriculture. His studies have included monitoring, modeling, and analysis of shallow groundwater flow and salt transport, and water quality related to irrigated agriculture, open channel hydraulics, and uncertainty in water resources systems, as well as field monitoring and evaluation of irrigation and drainage systems. Dr. Gates has directed and participated in numerous research projects at CSU, and for more than 20 years, he has led an extensive research, education, and outreach effort to better describe and find ways to enhance the irrigated stream aquifer system of the Arkansas River Basin in Colorado. And he's currently studying similar issues in the South Platte. He teaches courses on fluid mechanics and hydraulic engineering, and served as a consultant to various agencies, conducted training programs, and has worked internationally on irrigation projects in Egypt, and collaborated in India, Sri Lanka, Australia, and Pakistan, and has lectured in China and Vietnam. So very happy to have the time of Dr. Gates today. And with that, take it away. Thank you so much for being here, Tim. I really appreciate it.
Yeah. And then try to kind of keep yourself on there as much as possible for the people on Zoom.
Well, thanks for the introduction, Karen. Hi, everybody. I'm glad to be with you this afternoon. And my experience in the South Platte River Basin began about 25 years ago when I was asked to conduct a short study on salt buildup in irrigated fields in our county here in Lamar County, but also in Weld County, which is on the western side of the South Platte Basin. Shortly after that, though, as Karen mentioned, my attention was kind of diverted elsewhere when I got involved in issues of water conservation and water quality down in the irrigated stream aquifer system of the Arkansas River Basin down in southeastern Colorado. And there I was privileged to work on a great CSU team of faculty and students over the course of over 20 years doing monitoring and modeling of some of those issues. And it's only recently, at the invitation of the South Platte Salinity Stakeholder Group that Karen briefly described for you, that I have turned my attention back to the South Platte River Basin, where there are similar problems that are occurring, and where I am still on a steep learning curve myself to understand those problems. Today, I want to brief you on some of the available evidence that has raised concern about salinity in the South Platte River Basin. And I also want to share a little bit about efforts that are recently underway to better understand it and eventually address it by finding solutions. Irrigation in the South Platte, which is illustrated here in this map, where you can see those green fields spread up and down the basin. Those are irrigated fields, began in the 1860s. And there are currently about 700,000 acres of irrigated ground in this river basin. And it consists of more than 14,000 individually managed fields that are irrigated. The crops that are grown are primarily corn and hay, a lot of alfalfa and other types of hay, as well as wheat and vegetables. So it makes it one of the most economically important regions of Colorado with regard to productivity of the land. In fact, it's been estimated that it may be on the order of $2 billion a year that is generated by irrigated agriculture in the South Platte Basin alone. We're all familiar probably with the benefits of irrigation. Irrigation allows us to have expanded and sustainable crop productivity. It also allows expansive green vistas to be developed in what would otherwise be pretty bleak, arid, and semi-arid lands, similar to where we live. It allows rural economies to develop and to thrive, and the lifestyles that are associated with those rural economies, which I personally have grown to admire greatly. But irrigation can also markedly alter the landscape, and it can shift the hydrologic environment. A major way that it does this is through what we call irrigation return flows. And that return flow is associated both with quantity and quality. There are a number of factors that are associated with irrigation water being diverted out of large rivers like the South Platte and its tributaries, or taken out of expansive aquifers like the alluvial aquifer that underlies most of the irrigated land in the South Platte Basin. That water is taken out of the natural system and put onto the land at rates that far exceed the natural rates in an arid or semi-arid environment like this. Then that water passes through the soil profile, and as it does, it picks up and dissolves minerals that are within that profile. The water that's used by the crop, of course, is a pure vapor that's driven off the land. And so it concentrates the salts, the ions of various forms that are contained within the water that's applied. They're concentrated within the soil as that evaporation occurs. So basically, out on the landscape of irrigated valleys like this, we have a massive distillery operation going on. So that concentration occurs, we put water on, we put it on in excess of what the crop uses. It pushes that water to deep percolation down below the soil profile. It enters into the shallow aquifer, causes that aquifer to rise. It causes water to then be driven by that by the rising water table and the gradients that are created, which are basically the difference in elevation between the water table that rises into the irrigated land and the level in the river, so that it pushes that water through the subsurface back toward the streams. And when it does that, it passes through a variety of rock and layers and weathered material that comes out of those rock, and it further dissolves through a variety of chemical processes, additional salts. So we have evaporative concentration, we have chemical reactions like oxidation and reduction, dissolution and precipitation of various mineral salts. There is a process called sorption that can delay the transport of salts by the actual soil or rock particles, causing the solutes to adhere to them. Volatilization can occur. The idea here is there's a lot going on. When you take water out of the hydrologic system and spread it over thousands and thousands of acres of land year after year after year, you get the idea of what's happening. So it affects what we see develop out on the agricultural land. And one of those things it develops is accumulation of salt via these processes that we've described. And as the salt accumulates, it affects the land and the water itself in a variety of different ways that are considered to be degradation. And ultimately, it will lead to decline in crop yields because crops have a hard time getting the pure water they need out of a solution that is heavy in solutes. And so it causes a decline in the ability of the crop to produce yields that are economically valuable. Well, growing concern about salinization of water and land has been occurring in the South Platte Basin over a period of time, and it's based primarily on what we might call anecdotal evidence. We can see the impacts. You drive around in certain areas of the basin and you see salts crusting on the surface. You see the impacts of declines in yield. But there has been a limited amount of data that have been gathered over the years. Those data have been gathered by a variety of different agencies at different locations and at different times. And they suggest to us that there is indeed an issue that needs to be given attention to. So I want to go over some of these data with you and talk a little bit about current activities that are underway to try to better understand this issue and then tackle it, hopefully. As far as groundwater salinity, most of the work that has been done to date has been done by the U.S. Geological Survey. They did work back as early as the 50s. Through in 1964, there was a report that came out, and then in the 80s and the 90s. And those studies, again, at limited locations within the basin, nevertheless gave a sense for the levels of salinity that are present in the groundwater. And if you average those data, you come up with something on the order of about 2,000 milligrams per liter that are present within the alluvial aquifer, the unconfined aquifer that underlies the irrigated land of the South Platte Basin. Northern Water did some additional studies back in the early 2000s. Their studies were not as extensive, but nevertheless, they demonstrated in their analysis that the total dissolved solids averaged about 1,600. So again, we're in that range of high thousands, around 2,000. Now this is average. There are places where it's higher. Well, just to give you an idea of what this might mean. Corn, which is still probably the most extensive crop in the South Platte Basin, albeit the acreage is diminishing because, in part, of salinization. But corn can tolerate somewhere around 1,200 milligrams per liter before the yield begins to decline. And when crop yields decline, in response to salinity, they tend to decline in a linear fashion. As the salinity rises higher, they go down in a linear fashion. But these salt concentrations that we see in the groundwater are affected by a number of different processes. I mentioned oxidation and reduction, which some of you who are chemists or familiar with chemistry will understand. But again, these are reactions that can drive otherwise solid or reduced forms of salts out of rock and soil into solution, and or preserve them in solution from being reduced back into a form that does not affect crop productivity. Sorption, as I've mentioned, is another process. Cation exchange with the negatively charged clay minerals that are part of the alluvium that makes up the soils of the valley. Dissolution and precipitation. So again, the idea here is that there are a number of different processes that are related to the underlying geology and the soils that are derived from that geology making up the South Platte Basin. The map on the right is just an example of a map of different geologic formations, and the green crosshatched areas are areas where shale lies very close to the surface. Pierre shale underlies most of the alluvial basin, and that formation is known to contain a number of salt minerals that are susceptible to these kinds of reactions and can be driven into the groundwater as well as eventually into the streams. Well, the bottom line issue of concern to agriculture is soil salinity. I mentioned that I did a brief study back in 1998, and in that study, we did surveys in about 32 fields in Larimer and Weld counties, and we found average electrical conductivity of the soil water extract to be a little less than 3 decisiemens per meter. Again, if you convert corn's threshold into this measure of electrical conductivity, some of you may not be familiar. When the salt concentration goes up, then the water can conduct electricity more easily. And so electrical conductivity is a measure of that ease with which the water can conduct via the ions that are in solution electricity. So an EC of 2.8 compared, and that's the average that we measure. I think the highest we measured was around 7. Compares to a corn EC threshold before it begins to decline in its yield of 1.7. So again, just an indication here, we've got some issues that we need to deal with. Northern Water did some work later, a few years later. They found that over 36 fields that they sampled, the electrical conductivity exceeded that 1.7 threshold for corn in 64% of the sampled fields. It was higher than 2.5 in almost 50% of the sampled fields. So again, what does this tell us? Something we need to pay attention to. What about the river itself? USGS, Northern Water, and Nearbo Consulting have done some studies over the last 20 to 25 years and found that the average total dissolved solids from the Henderson gauge on the river, which is right there downstream of Denver, ranges from about 600 milligrams per liter out to where you get, where you cross the state line into Nebraska, where it averages about 1,300 milligrams per liter. So we see over that roughly 200-mile stretch that the salinity has more than doubled in the river. The types of salts are mostly sodium and chloride, characterized by sodium and chloride near Denver itself. And then as we get downstream, close to the state line and in the Julesburg area, and upstream of that, actually between Fort Morgan and Julesburg, it tends to convert to a calcium, sodium, and sulfate type of dominant salt. Another problem that often arises in conjunction with major cations and anions, which are what we're normally referring to when we say salt, are trace elements like selenium that even in very, very small concentrations, not milligrams per liter, but a few micrograms per liter, can threaten the health of aquatic life in the stream. This is a plot by Nearbo that was based on a study that was just released this year of some measurements of selenium all the way along the river, about a 250-mile stretch. And you can see the aquatic life standard there. Now, doesn't look like we've gone too far above it yet, but there's reason for concern. Concentrations are getting somewhat high, especially down towards the lower end of the river. By the way, EPA just, I think, lowered their chronic standard to 3.1. So they're saying we really ought to push it lower here in Colorado. I don't know if we will or not. Uranium is an even bigger issue. Uranium along the river over that stretch, you know, between what's marked here is about 120 down to 250 miles, now exceeds the drinking water standard of 30 micrograms per liter. Municipalities have a concern about salinity. It's not just agriculture. On this map, the little green dots show municipal wastewater treatment facilities that are located along a portion of the river valley. And you can see there are quite a number of those. And near those locations, generally there's treated effluent being released back into the river. Well, sometimes when you're out in the agricultural community, you hear people talk about, well, those cities, they're dumping all that salt into the river from their treatment plants. And so one of the concerns that municipalities have is, well, is this true? I mean, how much are we putting in compared to what's coming in from agriculture? And so they want to know, what is the relative contribution of their effluent to the salt problem that we're seeing in the South Platte? Water providers, on the other hand, are looking at the need to provide water at concentrations that are less than 500 milligrams per liter, which is becoming increasingly challenging along the South Platte River. A lot of municipalities now have gotten water from the West Slope. They've gotten good quality water that they're now able to mix with water that they take from intakes out of the South Platte River. But within just a few years, they're going to lose access to that better quality water, some of them. And they're saying, what will we do then? So this is a concern to municipalities. Overall issues of concern, when you just look at ag and municipalities and industrial concerns, let me summarize them for you. People just want to know, what really is the spatial and temporal pattern of salinity in our streams, in the groundwater aquifer, and in the soils themselves? We've got sprinkling little bits of data that have been collected here and there. But one of the other issues about that is that that data collection has been by this group, by that group, using this method, that method, very little coherence over a long period of time. So there's a concern to understand better what's really going on. What's the relative contribution to the river salt from municipal effluent and runoff from pavement, where road ice or where road salt is put as a de-icer on roads? How does it compare to the salt that's coming back from non-point source origins off of agricultural land? What's the severity of salinity in terms of its impact to the farmland, not just to corn, but to hay and to wheat and primarily the extremely valuable vegetable crops that are grown, particularly around areas like Brighton and others in the South Platte Basin, within, mainly in Weld County. Effects of expanding sprinkler irrigation. More and more farms have adopted sprinklers. The bulk of the irrigated land is now sprinkled with center pivots as opposed to flood irrigation. And one of the problems with center pivots is they cannot put the water on at a rate adequate enough to produce leaching, cleansing of the salts out of the salt profile. So what's happening on these sprinkler irrigated fields is that salinity is rising and productivity is beginning to be impacted by that. Long-term impact of recharge ponds that are used for well augmentation. When farmers decide to go to wells to get their water, to run their sprinklers, they have to provide water from another source, a reservoir or a canal, to recharge the aquifer to prevent their pumping from taking too much water out of the river in the subsurface without returning an adequate amount of water to mimic or match what was happening historically when they were dumping water on by surface irrigation. So when you start changing the patterns of irrigation, you alter the return flow patterns and you impact the in-stream flows, which impacts the ability of the person downstream to take the water they need under our prior appropriation system. Influence of salinity on municipal water supply and wastewater treatment, which we mentioned. Implications of dissolved salts and trace elements on aquatic life. The potential of different types of strategies to actually bring about a lower salinity level on the land and in the water. And then if we do that, what's it going to cost? Can we really do it in an economically feasible way? So we have begun recently a process made up of two major stages. The first stage is what we call problem characterization. We just need to understand the problem better. What is the nature and the extent and the severity of salinity throughout the South Platte Basin? And in order to do that, we've identified two phases. The first phase is to get out there and just collect a lot of data to describe salinity and to be able to assess its current state. There will be a second phase that will extend that data collection based upon what we learned in the preliminary phase. And then we'll begin to focus on not just characterization of what's out there, but what are the impacts of what's out there? What's it doing to agriculture? What's it doing to municipalities and to industries that use the water? And beyond that, to identify the sources and the controlling factors. And we know there are many possible sources, but we're not sure what sources are priority and they're making the most contribution versus those that may be making little contribution. The next major stage will then, based upon that data, will be to get out and explore alternative solutions to the problem. The characterization, again, as I mentioned in this phase one, which has gotten underway recently, is to figure out the severity and the variability of water and land salinity. And then to ask where and how should further efforts be focused to refine our understanding, but also to build a database that we're going to need to search for solutions. So we're getting out and we're collecting data first, processing that data, analyzing it to describe just how bad it is, and then moving on to this development of a plan for an extended phase. But all along, it's extremely important to be getting input and guidance from the stakeholders, the folks out there that are affected most by this, and who by experience understand it in terms of its effects as well as its likely sources. So our work will be guided to a significant extent by the South Platte Salinity Stakeholder Group and others. What we've started doing has been undergirded by identifying 7 different regions within the basin. And those regions we've identified based on the stream network, on variations in soils, on the subsurface geology. And in those 7 different regions, which are labeled again here, this summer we got out and started interacting with growers and traveling around, talking with people, getting people who would be interested in allowing us to do measurements on their fields. So we've installed 15 groundwater monitoring wells at sites up and down the valley and have started gathering data. And just this summer, just the data that we've gathered over the last couple of months has indicated in these areas that the depth of the groundwater varies from 5 feet below the ground to greater than 39 feet below the ground. So there's a lot of variability. And the groundwater salinity is less than 1 decisiemens all the way up to more than 4 decisiemens per meter. So again, we're beginning to learn a little bit more, and we hope to extend this in the coming years. We then will turn our attention to searching for solutions, and that's going to require that we go beyond just characterization to trying to use the data that we've obtained to support the development, the calibration, and the application of computational models. We're envisioning using the SWAP model that's coupled with a salt, that will be coupled with a salt transport module. And we'll use the model to study the impact of possible climate change into the future, land use changes, and then water and land management strategies that could be implemented to control salinity. Those best management practices that we want to examine include reducing excess irrigation applications to not have any more depercolation than we need to have, because again, that drives flows across the rock in the mineral-laden soils that are derived from that rock and pushes it into the streams. We want to control canal seepage. There are hundreds of miles of earthen canals that traverse the valley of the South Platte Basin, and they seep pretty significantly into the groundwater. We want to ensure that there's enough leaching occurring under sprinkler irrigation, and we want to look at what the impacts of altering irrigation patterns that are currently under sprinklers might be. We want to look at possibly relocating some of there are hundreds of recharge basins in the South Platte Basin that are used to recharge the aquifer to make up for the impact of deep well pumping out of the aquifer. And if those recharge basins, if the river is here and you got a recharge basin here and there's a near surface shale that is present between the recharge basin and the river, then that's probably not a good situation. We're causing that water to move through that shale, and if it contains nitrate and dissolved oxygen, redox reactions will dissolve that material and push it into the river. Almost none of those recharge basins, when they were developed and installed, were designed based on water quality considerations. It was all water quantity. So we need to take a second look at that. We need to lower excess fertilizer and manure applications. Those cause chemical reactions that can drive more salt into the system, enhance the treatment of urban effluent, find the control of road salts that are coming off of our city pavements and making their way into the stream. So we have some current projects that are underway with the Colorado Ag Experiment Station, Colorado Corn, Colorado Water Conservation Board. And we just submitted a proposal to USDA that we're hopeful about. And then we hope to prepare another proposal to the Colorado Water Conservation Board Water Plan Grant Program this December. Again, with the idea of giving us the resources to hopefully better identify the problem. But beyond that, try to find ways to solve it. So I appreciate your attention, and I'll be happy to answer any questions that you might have or listen to any comments that you might want to offer about our work. So, yes, ma'am.
I have a question on like source of salinity, like when is like did salinity come because people started divulgating and
Yeah, again, this is part of what we're trying to figure out. As I mentioned, we believe one of the major sources is the underlying geology of the basin. So when you put a lot of excess water from irrigation into the soil, it makes its way down into the groundwater, fills the groundwater up, and then it makes its way adjacent to these rock materials that themselves contain salt. And then when you're putting nitrate and there's dissolved oxygen in that water that's coming down into the profile, that those what we call oxidants actually will cause more dissolution of those salts out of that rock, and then it gets pushed back into the streams. The other thing that happens is that when we over irrigate, the water table itself rises up close to the ground surface. And you're familiar with a sponge, right? I mean, when you've got an unsaturated soil and you've got a water table that's real close to the surface, and you've got evaporation occurring and transpiration, it will pull that water by capillary action up from that shallow groundwater, and that shallow groundwater contains salts. So the salts build up in the soils. Okay, so that's a source. But some people think that some of the salt is coming from municipal wastewater, as well as what's running off of the roads in our municipalities. Yeah. So these are some of the places where we think it's coming from, but again, needs to be studied further because there's still not a whole lot of good, solid data that's been gathered. Yeah. Yes, ma'am.
So building off of that, is anyone looking at hydraulic fracturing and fracking fluid as a source of salinity?
From what I understand, yes, there have been some studies on that. I am not personally familiar with that. I would say from a quantity perspective, you know, when you just look at it relative to the vast quantities that come off of these, you know, again, 700,000 acres spread along a couple of 100 miles, it definitely can have an impact, but would be very small, you know, compared to that. Yes, sir.
Is this a problem we've been having since, I guess, the 1860s when we started irrigating, or
Yeah.
has something changed to make it, you know, noticeably worse recently?
Yeah, it's always been around. I mean, in arid and semi-arid areas, you have salts that build up because of evaporative concentration, right? But when you irrigate year after year after year, and you're putting on excess flows, and you're also, again, adding to those flows nitrates, for example, that are present in that water and making their way down into the subsurface, then you can accelerate those processes, and the magnitude becomes greater than what it was under natural conditions. But if your question is, are you ever going to eliminate it? The answer is no, we will not eliminate it. All we can hope to do is lower it. And we believe that it can be lowered. There are ways through improved irrigation efficiency, improved fertilizer management, altering what's, again, coming out of wastewater effluent plants and that kind of thing, that we believe you can lower it. We still don't know how much. And that's part of what we're trying to figure out. But there's a tremendous economy that's based upon all these activities, both in urban and agricultural areas, that are concerned to know that. I don't know if I answered your question very well. Let's see, there was somebody else. Yes, ma'am.
What are some of the biggest roadblocks or barriers you've experienced in these coalition groups as you try to communicate this science? Like where or if are the discrepancies among the stakeholders?
Well, you know, part of what you hear, again, because we don't have an adequate database yet, you hear people kind of, in a sense, there's a lot of finger pointing going on in terms of, well, it's, you know, they're the ones that are mainly responsible for this. And we're hoping that by gathering more good data, we'll get an idea of the relative contributions of different practices that are going on. Again, I mentioned this. I mean, again, when you go out and you talk, even this summer, when I can remember 2 or 3 farmers talking to them and then pointing to the cities as being one of the big problems in terms of the salt concentrations that are in the river. I had to tell them, actually, I don't think it's true. I think most of it's coming from ag land, but we still don't have a whole lot of data. Cost, as you can imagine, is always a concern. There's been a lot of money invested in augmentation strategies putting these recharge basins, hundreds of them, spread out all over the valley. Now we're coming along and we're saying maybe they weren't put in the right place. Well, you can imagine the pushback you get from that. Like, whoa, are you telling us that we need to move these things? Do you realize what that would take? All the process we had to go through the water court to even get it approved in the first place. That's some of the resistance that I'm hearing. Those are examples. I don't know if that helps. Yeah. Yes, sir.
I was curious, what would you recommend to ensure adequate leakage for the sprinkler systems?
Yeah, well, it depends on the soil, in that particular field and the crop and so forth. But usually you need to apply somewhere around 10 to 20% more water than what the crop is actually using in order to have adequate percolation below the root zone to push that salt out of the profile and maintain an acceptable level of salinity in the soil. And that is very difficult to do with center pivots. Right now, they're just not designed to put water on at a rate. They can barely keep up with the evaporative demand, much less put it on at a rate that exceeds the evaporative demand to an extent that they can adequately leach. Yeah.
Do people do anything about the time of day they use their center pivots and stuff to maybe like maximize?
I'm sure they do, but I think a lot of times, again, they just have to run them almost continuously just to keep up at certain times of the year. But I don't know enough about how many people are actually trying to, for example, go more to nighttime irrigation, where there might not be as much evaporative loss as you might have, during the day. I wish I could answer you, but I don't know. Let's see. Yeah, I just want to make sure everybody that wanted to ask. Yeah.
Oh, yeah, so I had the same question related to the center pivots. Like, how are the farmers responding to, like, what kind of crop they end up planting, given that center pivot makes like, so for instance, things like rolled up in the soil?
Well, I don't know. I don't have a lot of data on that other than just talking with growers. But they indicate that they're beginning to see people move from to more salt tolerant crops, away from crops that are more susceptible to salts. So I'm hearing that's happening, but I don't have good data to really quantify that right now. Yeah. Yes, Tom.
The geologic salts in the basin in the materials, how much of that is original from the original materials, or how much has come in through past hydrology,
Yeah.
past seams?
Yeah, good question. I was just reading about, I mentioned the Pierre Shale. It's considered to be the major culprit. And my understanding is that to date, the thought is that the bulk of that is is coming out of previously dissolved materials. They're mineral salts, like, well, for example, gypsum, calcium sulfate that's present within that shale. It's not like iron sulfide, where you would actually be oxidizing that sulfide into sulfate. That's my understanding, is that right now they think a lot of it was what was, is part of that material is part of the long-term hydrogeology and not just the geology, if that makes sense.
So it's an old sea basin, and salts came in.
Cretaceous materials are what they are saying most of these sources are. So that's, yeah.
Have quite a bit more experience in the Arkansas River Valley. Has the work that you've done there begun to show reductions in the salinity and improvements?
They have just in recent years, Robert, begun. And a lot of this has been pushed by CDPHE based upon work that we've done. They've begun getting out and starting some what they call pilot programs in areas where they're trying to get their growers to use more efficient irrigation, control canal seepage, and those kinds of things. So there are efforts underway, but it's just beginning. I don't know of any widespread adoption of these things that has yet gone on, to my knowledge.
We've got one question in the chat. How much of the municipal effluent is actually plant traits?
I don't know. I don't know. I understand that, you know, that some nutrients, of course, do come back into the stream. And some people have pointed out that when you start talking about things like phosphorus and nitrates, that you've got to kind of balance your concern with the fact that those are actually beneficial. Now, where they're most beneficial, though, is when farmers use that and lower what they're putting on their field otherwise. But if you're still putting a lot of fertilizer on your field and you're getting the fertilizer in the water that's coming out of the river, then you hadn't benefited the system much. And that I think is a concern. If you're going to utilize nutrients that come into the stream that could be beneficial, then you need to stop putting more nutrients on the land from manure or commercial fertilizers. We're probably over time, aren't we? Yes. Thank you. Right. Thank you for
No problem at all.
It was a big concern. You weren't going to be able to get that other one.
I got it.